Welcome geometry students, this is Mr. Klinkerman. From time to time this will be Mr. Pollock as well, coming to you with a video about how to do geometry. Now, we told you about the flipped classroom concept, and the idea is that we will teach you how to do the math from home through videos such as the ones you're about to experience. And then you will go into class and you will apply the skills that you're learning within the videos. Now, one of the things that you ought to be doing when you're watching these videos is taking notes. I know you're not in the classroom, but if you're wise, you're going to write down some of the ideas that are presented to you here. Also, it would be a good idea, since you won't be able to ask questions during this presentation, if you write down questions that you know you're going to want to ask, so that when you get to class, you will remember what your questions are. Alright. Now, for today, you can see that we're in section 1.4, and we're learning to measure and classify angles. And there are two learning goals, and I'm going to make one video per learning goal. The first learning goal is that you're going to be able to measure, name, and classify angles. Now, we did a little bit of this during the warm-up in class the other day, and so it shouldn't be anything that's brand new to you, yet it is something that you ought to pay careful attention to. And then secondly, in the next video, you will focus on learning a goal that says that you will be able to use the angle addition postulate to find unknown angle measures. Well, alright, let's go on and work on goal number 1. And if you remember then, goal number 1, measuring, naming, and classifying angles. And this is the thing that ought to not be new to you whatsoever, because, again, we did it in the warm-up. I want to talk about, first of all, how you name an angle. Now, remember that there is one important thing to keep in mind when you're naming an angle. The vertex of the angle is the most important point. And so, simply, one of the ways that you can name an angle is just as angle B in this case, because B was the vertex. But you can also name angles using points that are on either side of the angle along with the vertex. And just remember that when you do that, you have to put the vertex in the middle of the name. So one of those names that you could give is angle ABC. Alright, you can see that we picked a point from one side of the angle and a point from the other side of the angle, but put the vertex in the middle. Now, you don't have to name it angle ABC, you can also call it angle CBA, just as good. Alright, well, let's move along here. What if I were to put another point on the diagram? I'm going to put a point G on that ray BA, that top side of the angle, if you will. Well, now there's two new names that I could give to the same angle, but it could still be called any of the previous three as well. Now I could call this angle GBC if I wanted to, or I could call it angle CBG. Hopefully that's making some sense to you. Alright, now none of that should be brand new to you. However, this next part, it could be new to you. We're looking at measuring, naming, and classifying angles, and in particular, what I'd like to do right now is learn how you measure an angle. And if you remember writing down the postulates within this section, you remember something called the Protractor Postulate. And basically the Protractor Postulate explains to you how you can use a protractor to measure an angle. Alright, well, here we go. I'm simply going to put that angle ABC on a protractor. And what you need to notice then is that on the protractor I lined up one of the sides, this one down here, so that it goes through the 0 on your protractor. And then the other side of the angle, the way we're going to find the measure is simply we're going to see where does that ray intersect the protractor. What number does it intersect at? And you're going to notice that it intersects at a couple different places. It's going to intersect, well, if you're using the larger numbers here, you can say that's 126. If we're using the smaller numbers here, you're going to see that that corresponds with 54. Right, between the 15 and the 4. But the one that we need to choose, since this is an acute angle, is going to be the 54. Alright, so quite simply, we can say that this is true. That the measure of angle ABC equals 54 degrees. One of the things that I want you to notice here is when I wrote that the measure of angle ABC equals 54 degrees, I put this little lowercase m in front of the name of the angle. Anytime you're trying to write the measure of an angle, you need to use that little m in front of the name of the angle to indicate that you're writing the measure. Fairly simple, but it is super important that you do that if you're going to be able to communicate geometry, and if you're going to understand geometry when it's being communicated to you, you have to understand these little notation things. Alright, now I showed you one way of measuring an angle with a protractor, and I'm going to show you another right now. It's still using the protractor postulate, but what you're going to notice is that this time the sides of the angles, ray BC and ray BA, neither one is lined up with the 0 on the protractor. Well, here's where the protractor postulate begins to resemble the ruler postulate that you learned in a previous section. You might recall that in the ruler postulate, what you could do is you could use the numbers on a ruler as coordinates, and that's exactly what I'm going to be able to do here with a protractor. I'm going to be able to use the numbers that ray BC and ray BA intersect on the protractor as coordinates, and I'll be able to use those coordinates to find out what the measure of angle ABC is. And it's just going to be by finding the absolute value of the difference of those coordinates, the same way the ruler postulate worked. Alright, now notice that point A, well, it's going through, let's say 136. Alright, that's its coordinate then, is 136. And then ray BC, well, it looks like, if I use the bigger number for this other one, I can use a smaller number here. Looks like that's about 26 degrees. So, if I want to find the measure of that angle, then all I got to do is subtract those coordinates. All right, I'm going to find the absolute value of the difference between C and A. Alright, now when I type these up, I use slightly different coordinates that I did when I wrote them down a moment ago. I'm using 27 instead of 26 for C, but it doesn't change anything. We're going to say that this angle measure, ABC, equals the absolute value of the difference between 27 and 136. And the difference between 27 and 136 happens to be 109, a negative 109, and the absolute value of that is a positive 109 degrees. Alright. At this point, you ought to understand how to use a protractor to measure some angles. It's a great idea to pause the video right now and practice using your protractor to measure some angles from your textbook or from a worksheet or angles that you draw. Any of those would be good practice. So pause the video for a moment, try some of those, then come right back and we'll do a little bit more with measuring angles. Hopefully you've practiced measuring some angles on your own with a protractor now. The last thing I'd like to do is take a look at this picture that I've got right here, and we're going to use it to find the measure of the indicated angle and classify the angle. Well, let me indicate an angle measure to find, and then that'll make a little more sense. We're going to start off by trying to find the measure of angle KVM. And so we'll use the protractor postulate to do that. You're going to notice that point K is at 90 degrees and that point M is at 0 degrees. And so the absolute value of the difference between 90 and 0 is of course 90 degrees. We're going to be able to say then that the measure of angle KVM, that's a horrible V, excuse me, but that measure is going to be 90 degrees. And again, notice that when I was writing the measure of the angle, that I used that lowercase m to indicate that I was giving the measure, not just referring to the angle by name. Well, the second thing the directions ask us to do here is to classify the angle. Simply enough, we're using the angle measure to classify the angle, and you guys know very well that this is going to be a right angle because it's got a 90-degree measure. And in fact, on the diagram, often you'll put this little green box right there. Doesn't have to be green, obviously, but you'll put that little box to indicate that you've got a 90-degree angle. All right, let's try another angle measure. This time we're going to find the measure of angle MVL. Let me highlight that angle there so we know what it is we're dealing with. Alright, so angle MVL. Alright, we'll use ray VM and ray VL. And I think you can tell then that the coordinates of ray VM and ray VL, the coordinates that they pass through, are the 30 over here and the 0 over there. That doesn't make a lot of sense, does it? Because this is clearly an obtuse angle. We can't use a 30 if that's going to be 0. We're going to have to use the 150 right there. And so then the measure of angle MVL is going to equal 150 degrees since it's 150 minus 0. And then we already said it's an obtuse angle because its measure is between 90 and 180 degrees. There you go. It's an obtuse angle. Now, the next two angle measures I want you to try to find on your own. So go ahead to the next slide here. I'll move you along there. And then pause the video right now. See if you can find the measure angle PVM. Then unpause and you can listen to me tell you what the actual answer is. So go ahead and pause for a moment, please. Great, hopefully you found the measure of angle PVM at this point, which I'll go and highlight. That's going to consist of sides VP, ray VP, and ray PM. Now you notice that this pair of rays that form the side, they're opposite rays, right? Ray VM, ray VP, they're opposite rays. One going through 0 degrees, the other one's going through 180 degrees. That means the measure of angle PVM is going to equal 180 degrees. And you ought to know that the classification for an angle that's 180 degrees is a straight angle. Alright, we've got one more angle for you to find. Go ahead, pause the video, see if you can find the measure of angle LVK on your own right now. Alright, angle LVK consists of rays VK and VL. Notice that neither one of the sides ends up on the 0, and so we're going to have to use the Protractor Postulate in order to make this work. Let's say that, we'll use the smaller numbers here, let's say that ray VL passes through the 30, but you could easily say 150, and that ray VK passes through 90. Alright, well then the measure of angle LVK would equal the absolute value of the difference of 30 and 90. And of course, that's going to give you the absolute value of negative 60, which is going to be 60 degrees. Now, I've been emphasizing this little m over there. Also, always include units. And for an angle measure, the units is that little degree symbol. And then since the measure of angle ALVK is between 0 and 60 degrees, that means its classification is that it's an acute angle. Hopefully this video has made a lot of sense to you. You can pause, rewind, all that as much as you need to understand the concepts that are here. There's one more video for you to watch from section 1.4. Hope that you've enjoyed this, you've learned a lot, and go on to the next one and see how you do. I'll see you in a bit.